Okay, here's a similar problem. It gives us one of the complex roots. It immediately tells you the other one's 1 minus I. And then it wants the other complex roots, so unfortunately we're going to have to do division again. We're going to have to do x minus 1 minus I, and x minus the other one, which is 1 plus I. Okay, we have to FOIL this out, so it gives us x squared negative x times 1 plus I minus x times 1 minus I, and then plus 1 minus I times 1 plus I. So this gives us x squared minus 2x here, and then here we have 1, middle terms cancel, negative I times positive I is negative I squared, so it's 1 minus I squared, which is negative 1, so 1 plus 1 gives you 2. So I'm going to have to do long division now into this polynomial x to the 4th minus 6x cubed plus 15 x squared minus 18x plus 10. So the question is, what do I put up here to multiply by x squared to get x to the 4th? Put up an x squared, it gives me x to the 4th, follow through, negative 2x cubed plus 2x squared. We're going to subtract, and we get negative 4x cubed. 15 minus 2 gives us 13x squared, and we're going to drop down to negative 18x and start over. So what do I multiply by x squared to get negative 4x cubed? That'd be negative 4x. That gives me negative 4x cubed. That gives me positive 8x squared when I multiply the next one. And then negative 4 times 2 is a negative 8x. When I subtract, I get negative 4x cubed minus a negative 4x cubed, which cancels. 13 minus 8 gives us 5x squared. Negative 18 minus a negative 8 would be negative 10x, and I can drop down to 10. All right, let's start over then. Try to do green, I guess. So what do I multiply by x squared to get 5x squared? That'd be 5. Follow through. 5 times negative 2 is negative 10x, and 5 times 2 is positive 10, which is good because we have no remainder. So there's our quadratic that I should have used to use the quadratic formula on. So it's opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. This is 16 minus 20, which is negative 4. And this is 2. So this turns into 4 plus or minus the square root of negative sign is I, the square root of 4 is 2, so it's 2I, and then divided by 2. So this gives us 2 plus or minus I, which we can write as 2 plus I, 2 minus I is our two other complex zeros. Okay, another one. This one has a root of x equals 3, so let's divide 3 into it to find out the irreducible quadratic that's left over. 4, negative 16, 21, negative 27. Drop down the 4, multiply gives you 12, add it gives you negative 4, multiply gives you negative 12, add it gives you 9, multiply gives you positive 27 with no remainder. That's perfect. So our quadratic is 4x squared minus 4x plus 9. That has no real zeros, but we can find the complex zeros by using the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So that'd be 4 times 4 times 9, 16 times 9, 144. 16 minus 144 gives us negative 128. So this is negative 128. I need to simplify this, so I'm going to look for the biggest perfect square that goes into 128, which is 64, obviously. So I'll make this 64 times 2 instead of 128. And then this becomes 4 plus or minus the square root of I, or the square root of negative sign is I. The square root of 64 is 8, and I still have the square root of 2 left. And then in the bottom I have 8. So this simplifies into 1/2 plus or minus I square root of 2. So I have 1/2 plus I square root of 2, and I have 1/2 minus I square root of 2. Okay, and this is the toughest problem. I might not be able to put this in the test because it's just too long, but it's a really good problem to practice with because it's probably the hardest one. So we have two zeros. We have the square root of 2 and negative square root of 2. So here's two of the factors right away. The other two factors then are x minus this 0, 6 plus 9i. And then we have another complex conjugate of this number, so it'd be x minus 6 minus 9i. So there's our polynomial. It's the fourth degree. It's got these three roots that it said, plus it has to have this other root because we know that complex numbers come in pairs. And we can make it go through this point last, but before we do that we have to FOIL this whole thing out, which I know is a lot of work, but we have to do it. X times x is x squared, and then the middle terms are going to cancel here. Square root of 2 times square root of 2 is 2. So there's our first two FOILed out. Now let's do these last two. So we're going to have x squared, and then negative x times 6 minus 9i, and then negative x times 6 plus 9i, and then this would be positive 6 plus 9i, 6 minus 9i. So we need to simplify this. Once again, we know the pattern here. We know that these xi terms always cancel here. So it's going to be negative 6x and negative 6x added together to get negative 12x. And then over here, with these two complex conjugates multiplied together, we know the pattern there as well is multiply the first times first and last times last would be negative 81 I squared. And the I squared turns into negative 1, so it turns into 36 plus 81, which gives us 117. So there's our other polynomial right here. So it's this times the x squared minus 2. We still have to FOIL this out. So x squared times x squared is x to the fourth. X squared times negative 12 is negative 12x cubed. X squared times 117 is 117x squared. Negative 2 times x squared is, I'm going to write this underneath this one because I'm going to end up adding those together. I have 2x squared. Then I have positive 24x. And then negative 117 times 2, 234. Okay, I can add these together. My final polynomial is x to the fourth minus 12x cubed plus 115x squared plus 24x minus 234. Now that's my polynomial right there, fourth degree, but it did say it has to go through this point, 0, 144. So unfortunately I'm going to have to stick in 0 for x and 144 for y and find out how I need to adjust my a term in the front of this thing. So let's go ahead and do that. That'll be 144 equals a times, all these get canceled off, plug in a 0 for x and you just get negative 234. And divide both sides by negative 234 and a equals negative 8 over 13 as a reduced fraction. So that goes right in front here. And I think you can just enter it in like this. I think you can just take this polynomial that we had in red and put the a in front, so it'd be negative 8 over 13, and then put this in parentheses or brackets. So I'll use parentheses. And I think that should do it right there. And they already have the y there. So basically all we have to enter in then is this right here. All right, I hope this helps.